So how are we going to replace or return carbon dioxide back to the earth from the atmosphere?
Yep, the legacy carbon dioxide is equivalent, we've already put there is equivalent about 40 times our current annual emissions. So we've got a lot to put back. The different levels of detail. At the top level, you can put it back in the ground. You can make new rock out of it, or you can put it in biological systems, which are much shorter term. You can put it in the ocean. That's can be somewhat complex. So in the ground, there are two primary things. You can take carbon dioxide that you've captured and pump it down into a formation, which would be basalt or olivine, which is the most common mineral on Earth. And you put it down there, and as they've demonstrated in Iceland, when the Climeworks captures carbon directly from the air, CarbFix puts it down in rocks, drilled holes, and it turns into carbonate rock within 2 years, most of it within 1 year.
That's phenomenal. Well, I'd like to welcome everyone to the Climate Change Disruptor podcast. We're honored today to have Gene Fry, who is a global warming consultant who has been studying climate change for the better part of the last century. So from 1989, I understand, in November of 1989, fundamental shift happened in your world that you became aware of more of the challenges that we're facing today.
Yes.
And where were you and who did you hear talk about?
I went to a piece of a conference in Raleigh, North Carolina, my house husband here, and went to a session where Al Gore, Carl Sagan, and David Ryan spoke. David Ryan changed my life. His boss was Jim Hansen. The paper that they and 3 others did, there's a PowerPoint about the forthcoming paper, showed that the Earth's surface temperature at doubled CO2 in 2059, which is kind of a business as usual, or maybe even super business as usual scenario, had progressively more and more drought. And by 2059, the end of their simulation period, covered 45% of Earth's land surface with once a century drought. That caught my total attention and has held it for the last third of a century. In 2007, I came across a graph in a paper for Green Investment, and it showed, looking backward, a paper by Carl Trenberg, Aguadai, and couple others, that looked back at the trend in drought, and more or less once a century drought could be inferred from it. And the hindcast from that paper, looking back, looked just like the forecast from the paper by Ryan Hansen et al. Said, oh my God, forecasts have a way of being wrong. I worked in the electric utility industry for many years and learned plenty about forecasting. And there's wrong and there's useful. Everything's wrong, but some things are useful. And I was just struck by how right on that was, and that was scary.
Anyone who's been exposed to the material understands that we've known about climate change all this time. We've been in a position where we have not implemented as many fixes and technologies. And yes, we can be wrong. We can do something for the right reason and have to evaluate and change, but we're closer to mitigating climate change the more of us who work together and attempt different technologies in order to affect a better outcome. What you were talking about there in 2059, almost all of North America would be a desert.
Yeah, everything south of Canada, pretty much. They were using vegetation classification stuff, and I don't remember the details, But yeah, we're looking at the major food crops. They had two models, one from NASA and one from NOAA. And one of them had 30, and they had, I think, 4.2 and 4.5 degrees Celsius warming from the baseline 1951 to 1980. And the U.S. food crops, wheat, corn, and soybeans, production declined 30% in one model and 50% in the other. Those are very striking. And I hear about Al Gore worry about sea level. I said, well, yeah, that's a worry and people can see it. But civilization can collapse from lack of food before you see rise 3 feet. I've been saying that for 2 or 3 decades, and
Sure.
and maybe I'd alter that to 5 feet now. But
Well, they're all vicious cycles. When we're looking at the warming of the melting of the polar ice caps, the rising temperatures of the ocean, and the increasing tides that are going to be coming in, we are going to lose significant areas of population. And if you think about having to relocate, say, the city of Miami to northern Florida, just the logistics of it. And that's what we're looking at within a generation or two.
yeah, what I think in terms of is managed retreat.
Interesting.
And
And
I think we have a lot of unmanaged retreat in the United States so far. They're better at managing retreat in the Netherlands.
right. And I know that some of your research that you follow has come from Iceland with the injection of the carbon dioxide back into the environment. Is that correct?
Yes, CarbFix has done that with what Climeworks has done with direct air capture. Goes in the ground, turns into carbonate rock within 1 or 2 years. They're working with basalt there. There's a lot of basalt near the surface in eastern state of Washington, or the
Sure.
eastern part of Washington state.
And there are other things we can do. We can put these materials closer to the oceans, and they'll absorb some of the carbon dioxide from rain as well.
Yeah, you want to grind up mine tailings to increase the surface area, because the greater the surface area, the slower they sink, but the faster they take up essentially CO2 in the ocean. It's in ion form. It's not exactly CO2, but essentially it is. For our purposes.
We can talk about the different greenhouse gases. I know that you know more about methane than I do, and that most people do. And some people associate all the greenhouse gases into one, but we need to start reducing all of them. So whether it's on the energy side, where we stop using as much natural gas and go to solar and wind turbines, or on the other side of reducing the gases, I find that fascinating.
Yeah, something that many people know we need to stop putting carbon in the air. Very few people know that we've put 40 times as much carbon in the air cumulatively as we are doing this year. Our emissions as a species are peaking now for carbon dioxide, but it's a plateau. It's not a sharp peak. It's gone down in the United States and more strong in Europe. It's gone up in China and India and much of the rest of Asia, including the Middle East with its oil capitals. I'd just like to add another way of taking carbon out, 2 other ways of taking carbon out of the air. One is similar to what you do in the ocean by putting ground up mine tailings there, but in this case, you put it on the land surface. The wetter the area, the better it is, and rain on this ground up mine tailings or something else that may be freshly mined, and that dissolves on the surface of the tailings with CO2 in the raindrops, and that also converts to carbonates, becomes carbonate rocks. and those generally get washed into the ocean, and that's a helpful thing to do. The other thing you can do, which is very useful for short term, but is real, it vanishes over the medium term, is biological. Forest soils, and forests hold a lot of carbon. Soils hold about 2 or 3 times as much as the atmosphere, and more than is in forests. That's especially true the closer you get to the poles, although in the tropics, it's mostly an above ground and very little below ground, and it's the opposite as you get toward the poles. The problem with that, putting it in soils, which you can do through organic farming and various other methods, is that as the soil heats up, as the climate gets warmer, the respiration of the soil speeds up, and you get more CO2 emitted from the soil, and at some point it becomes a carbon source rather than a carbon sink. You have the same dynamic at work on a physical sense in the ocean. When you heat up water, gases become less soluble and they tend to come out of solution. A friend of mine who was in grad school at MIT about 15 years ago, they were working on that and really worried about the ocean changing from a carbon sink into a carbon source. And that there's some interesting things going on in the Southern Ocean around Antarctica, with the sea ice is down almost a quarter from its beginning of the satellite record, and almost all of that change or ice loss has been in the last 5 years. Whereas in Arctic, you've had 20% loss instead of 25, but that's been much more gradual, and it's not been especially strong last few years, although it is much worse than what models used by the IPCC over a number of years have projected. Making some progress, but models don't cover everything. They're covering more thing year by year, but they got important problems, especially with clouds.
100%. I mean, if anybody doesn't really understand this, they can go to YouTube and look at the glaciers and how we've lost 70-80% of our glaciers in our Alaskan seaways over the past 25 years, where it was projected we were only going to lose probably 45-50% by this time. So things are accelerating in a bad way as we're trying to ramp up the deceleration at the same time. And there are days where I'm optimistic, and there are days where I'm pessimistic. I like to say that this saving the world isn't all that it's cracked up to be some days, but we all are trying to do our parts here. Tell me a little bit. Do you have this information on a website for us, Gene, that people can access it?
Yes, let's see. Let me just pull it up, my website up here.
And we'll also be sharing that in our show notes later.
So the website address is globalwarming-sowhat.com. I'll just leave that up there. And it has 20 web pages. This is the home web page. And you can navigate to other web pages. There are more than 2,000 figures. So there's an awful lot of stuff there.
100%. And this explains the science to everybody. We can, in a short form podcast such as this, we can hit a couple topics. We can hit the high notes. We can encourage and motivate people to learn more information. That is the goal of what Gene and I are doing here in the legacy portions of our climate change reduction mitigation system. But there's just so much information, it becomes overwhelming for people. What is a good way for people to follow you? And is there a social media channel that you also post to? Have you written any books that people can buy? Not yet.
I have one article that was published in a journal, although it's not peer reviewed. And if you go down most of the way to the bottom of this page, there's a link to it.
That seems like a great way for people to get started. And
Yeah, there it is, that one.
awesome. Interesting.
And you can read about the details about albedo changes, snow, ice, sulfates, other clouds, other things. Most of that. Yeah.
This is all very phenomenal information. Now, you started with a Doctor of Philosophy and a Master's of Divinity. So
yes, my first of two masters. Yes.
it's really interesting. You know, I meet such cool people in this field, but there weren't a lot of people who got their first degrees in geology. So
In theology, you mean?
Or theology, right? Well,
Yeah.
theology, what it shares the suffix, but it does not share the background that you would think that someone would come from to know as much about rocks and how they can help us mitigate some of the greenhouse gases that we discussed today. So you ended up into the energy field. You help people reduce their footprint a little bit through the utilities, and
Yep.
you've been and now you go out and do you help corporations? Where do you consult?
I get invited to speak at international conferences. They're usually pretty small conferences. And from time to time, I go to them. I do presentations to other groups. I'm not having anyone hire me, by and large, to do consultations. I'm turn 75 in a couple of months.
As I said, we're at the legacy part of our careers, aren't we? But
yes.
Yeah, we could still we're still out here trying to do the right things. It's so very interesting, and it keeps we're still learning, we're still evolving, we're still evaluating, we're still encouraging people to try some of these best practices. And I know Al Gore. Everyone points to him as a lightning rod for and against climate change, but he really did get to focus our energies and attentions to the problem. And now we're at the point where we actually have to implement, as I said, the solutions that we know work and the solutions that possibly can help us mitigate. And what would you say in terms of, other than Iceland, have people actually been doing more of this carbon dioxide reduction along these methods we discussed today?
There are projects out there, some scattered across the United States and Canada are the ones I've heard of more. Carbon engineering out of Vancouver or Whistler, or not, Squamish, I think it is, near Vancouver, are doing some things. I've not heard about where they're putting the carbon they capture, however. There are oil company, Occidental comes to mind, that have projects that are involved more, instead of taking carbon out of the air, they take it out of smokestacks of industries, whether they be ethanol power plants or oil facilities. Some of the ones that take it out of oil facilities pump it back in the ground to get more oil out. So it's not really, in my view, very helpful. We have this huge amount of legacy carbon that we've already put in the air that's raised CO2 levels from 280 at roughly 1750 to a little bit over 420 parts per million now. So we need to stop putting carbon in the air, and I think most people know that. And we've got an electric car for 6 years. We have a heat pump for our house for 7 years. Those are probably the two biggest things you can do as a consumer. But you also need to take carbon out of the air, as we've just been discussing. And it turns out that you can't do that fast enough. The CO2 removal industry is growing rapidly, but it's doubling every year or two, maybe. And if we're doubling 3 times a year, we might be able to get to the point where we have net zero well before 2050. And of course, we go to net negative after that. Net zero is not a magic number, but it's a very useful marker. We need to get far below net zero to survive as a civilization. The other thing we can do in the meantime, and it's far cheaper actually than CO2 removal, at least permanent CO2 removal, is to cool the earth by changing how much radiation reflects. Right now, it's becoming darker as the ice and snow melts. And as we clean up our act burning coal and burn less coal, you don't have as much sulfate aerosols in the atmosphere. And that's what we've done since 1979 to now, is about a quarter of the warming we experience is just from having fewer sulfates in the atmosphere. But that's going to be substantial as that comes off. Basically, about as much warm, almost as much warm, half as much warming as we have to date will be added as we quit coal.
That's been one of our goals. That's been one of our goals at Green Turbine, where we're trying to replace every single coal power plant around the world. And in America, it's on a for-profit basis, but for the third world, that's all donated materials that people are contributing towards.
Yeah, the interesting thing is that a lot of coal is being replaced in the United States. About a little over half the coal being shut down is replaced by natural gas. And burning natural gas has only half as much CO2 emissions per unit of energy as coal. But
however,
there are
we
leaks
can't be
in the natural
adding
gas
additional
transportation and extraction that very well may negate that advantage.
The green technologies have been great, and we're expanding them about half as fast as we need to in the United States. There are other countries in the world that have gotten to 100% renewable power. And I think that's something that we can all point towards and encourage. Again, these are not just individual decisions. Yes, heat pumps, solar on your roof, wind turbines in your backyard, electric cars. We do have to create microgrids to do that. That's why certain technologies are going to be better than others. That's why people can make money if they have a Tesla Powerwall in their garage and they produce the electric on their roof and they sell it at the highest point of the day to the utility, and then they get to fill it back up at night at a cheaper rate. There are many ways that we're doing this as a civilization. They all cost money. There's always a political cost. You guys, everybody out there needs to emphasize to their families that it needs to happen sooner than later. We're not at the point of solving climate change. We're at the point where we're mitigating climate change, and we're all trying to do as much as we can, as fast as we can to do that. So without too much further detail, I want everyone to go to globalwarming-sowhat.com to follow Gene Fry's work. It's amazing that someone has all these resources and materials in one place that people can access to get more information, to have these conversations, to move the political needle, to get people to start doing more of best practices. What an honor it was to have you on the Climate Change Disruptor podcast. My name is Ronald Hunt, and we do this to help people understand how to improve our children's lives and our grandchildren's lives. Thank you very much for being here today.
Well, thank you for having me.